All right, so did you see the infinite window? Yeah, if you've never seen the infinite window, you pull a window into itself while it's recording. All right, but all that aside, so today's lesson is on 14.4. We are dealing with combining functions. So one of the cooler things that we'll get to, I think you get to this deeper into calculus, but what would be a situation where I have a function that its input is another function? So that would be the f of g of x situation. But to get to that point, we got to learn how to basically combine our functions. So we have two different functions here representing discounts on a ring. One store is offering 15% off, while another store is offering 20% off. And I will tell you, or sorry, $20 off. I will tell you store B is a better deal. At least I believe. By my math. Yeah. So what we want to figure out, you should have them.
Yeah, I passed them out Friday.
But then we didn't do anything with them.
I got you.
Oh my god.
We want to figure out the difference between these two situations. So what's the difference between the two stores and which one's better? Now if we look at these, B gives you 20% off, or keep saying percent. B gives you $20 off. A gives you 15%. If you think about it right now, which one of those do you think is better? Percent, right? Because 15%, if the base price is 300. So we want to find the difference between them. So we essentially want to set up a function for each of these and then do the subtraction. So what kind of function would represent 15% off? Well, if we had the original item, let's say the original price is going to be X. So try to write a function for both of these. Let's say this is going to be my function A, and store B will be my function B. So take a second, write a function where X is your original cost. I gotta orient my screen, that's all goofed up. You don't need graphing calculators today. You really don't need any calculators today. So, hopefully what you thought about was to represent 15% off. I take away 15% of the X. So function A is really going to end up being 0.85x, right? With function B, removing a constant of 20 from the original function is going to be x minus 20. So hopefully those are the two different functions you got, 0.85x and x minus 20. From there, we want to find the difference between them. So I'm either going to set up function A minus function B, or function B minus function A. What would really be the difference if I switch the order? One's going to come out with actually the difference. The other is going to come out with, yeah, the opposite of the difference, like a negative. So if we set up our function subtraction, we can set up B minus A or A minus B. Either way, when we do the math, we see there's a difference between them of $25. Whether one's 25 more expensive than the other or 25 is less expensive, we then would analyze and put that in. Store B is going to be $25 more expensive. So that's why when we look at B minus A, we get a positive answer. B is more expensive. The price of B ends up being more expensive. So B is going to be greater by $25. Yeah.
Just by looking at that, you can tell that store is the better deal.
Right.
10% would actually.
That's why it's really basic, because we just want to introduce the idea of what we're doing. So we put both our functions in together, function B minus function A, and then we do the math to combine them. That's just a really basic intro. So if we look at our first problem here then, we have a function f that is 5x minus 7 and a function g negative 2x plus 1. I started the work for you. I want you to try to finish out the work and figure out what is f plus g of x. I started the work for you. I don't want to move on because I don't know how far it goes. And I'm actually going to pull up the notes so that it doesn't give you the answers when I don't want you to have them. So at this step now, what would we want to do next? Alex, what do we really do now?
Well, you add them, so you combine 5x and negative 2x.
Yeah, so we're looking for like terms now. So 5x and a negative 2x, I can rewrite this in the right order if I want to be able to see them. But that's going to give me just a 3x. And then I have a negative 7 and a positive 1. That's going to give me negative 6. So you should have seen that f plus g of x is 3x minus 6. Now when we have an input, we just plug that input in for the x. So please plug in the input for the x if you haven't yet. What do we end up getting, Jacob? Negative 15, because that's going to be negative 9 minus 6. And we get negative 15. Questions? Try that got it. Or, sorry, part B, finding the difference here. Now, this one is a bit more challenging, so I want to see who can actually get this. Be careful. It's easy to make a mistake here. We have 4 times 3 to the x, and what makes this tricky is that my variable is in the exponent. G of x is 3 to the x plus 2. We want to find the difference between them. So f minus g of x. And really when we say this, it's f minus g of x. F minus g is its own quantity. Anyone really know what I need to do here? What I do with those values that have the x in the exponent? Robert? What do you mean?
Like, since you have both,
Excuse the interruption. Could I please have Thomas Sturgis to the office? Thomas?
they can cancel them out.
Cancel what? Like, what do you mean?
Because it's subtracting. And you can hold 4 times the value. You can cancel out the x.
They can't cancel out. They can't disappear. How many 3 to the x's do I have right here? Right here. Like in my g of x. In my g of x. How many 3 to the x's do I have? 1. In my f of x, how many 3 to the x's do I have? So if I start with 4 3 to the x's and take away 1 3 to the x, guys, I can really rearrange this and say 4 3 to the x minus 3 to the x. Well, that really, if I want to write it, is a 1 times 3 to the x. So if I have 4 times 3 to the x minus 1 times 3 to the x, and I still have the minus 2 out here, it just becomes 3 times 3 to the x.
Plus 2.
Oh, yeah?
Oh, yeah.
The minus distributes and applies to both. That's how I get my minus 2. So what we should end up with is 3 times 3 to the x minus 2. But we still have to evaluate. So we're still going to have to plug in. Guys, can we stop with the fans? They're not doing anything. They're really not that purposeful, and you're just playing. Most of you. And what it is a whole lot of not focused. So now we evaluate this and plug in a 2 anywhere we see an x. What do we get, Ben?
25.
Yep. Because this is going to become 3 times 3 squared minus 2. That's 3 times 9 minus 2. That's 27 minus 2, which becomes 25.
You did it a different
Yes, because eventually, if you try to plug it in and then evaluate, as opposed to evaluate then plug it in, you'll get the wrong answer. Because order of operations gets screwed up. Yeah, so you have to find your combined function first before you can plug in and evaluate. So try this one. Now we've got 3 different types of terms. We've got an exponential term, a constant of proportionality term, like variable with coefficient, and a constant term.
On the top screen, is that F minus G?
On the where?
PG, the top one.
Yeah, sorry, my smart board's a little weird. I think I might need to swap out my board.
It's not as bad as Mr. Allen's.
Yeah, I've heard about his.
His is like all
His is
polka dot
horrible.
and
It's annoying.
goes up.
It looks like it's snowing
It's
constantly.
like snow. Yeah, it's like snowing on it.
See?
It's like dandruff all over the smart board. That's not
It's okay, Ben. It's okay.
I thought we were trying to find it.
Kale, do you have what our sum is? What do you got? Not the final evaluation, just the sum of the functions. So we're just looking right now for what is our f plus g of x. 5 to the x plus 3x plus 4. That is correct. So here is what you should get when you sum the functions together. We start with 3 types of terms, so we have to end with 3 types of terms. The only thing that we were actually able to combine, the negative 4 and the positive 8. Then we plug in and evaluate for f plus g of, is it 3? Yep. So 5 to the 3 plus 3 times 3 plus 4. What'd you get, Kale?
138.
It is 138. Because this becomes 125, this becomes 9, that becomes 4. Now, moving on from adding and subtracting functions, what about when we multiply and divide our functions together? So, when we multiply a function, this is especially where we have to do the work first before we plug in the value. So f times g of x. Do not confuse this with f of g of x. This is f times g of x. F of g of x puts one function into the other function. This, we're just multiplying the 2 of them together. So I've got 2 times 5 to the x and 3 times 5 to the x. These are essentially like scientific notation. We've got value in front multiplying by a shared base value. My 5 to the x and my 5 to the x are like a shared base value here. But because I have 5 to the x times 5 to the x, they're not going to stay the same like scientific notation does, because scientific notation actually doesn't stay the same. We just have special rules for how we work with it. All I have to do is deal with the fact that I have a number to a power and the same number to the same power. So think of it real easily. What if you had 5 to the first times 5 to the first? You get 5 to the second, right? So if you have 5 to the 1x and 5 to the 1x, you just get 5 to the 2x. And then I can take my 2 and my 3 and just say, well, this is really 6 times 5 to the 2x. If you need to write out why we group and do the 2 times 3, we group and do the 5 to the x times 5 to the x. And that is how we get that. If you ever don't know what to do, make it simpler to something you do know how to do and compare that with what you don't know how to do. Yeah.
Does the 5 to the 2x have to be in front of the 6, or does it not matter?
We actually like it coming after because it's easier to plug into there and Really, it doesn't matter because multiplication is commutative, but that's just the better way to write it. Just mathematically, that's how we like it. So now we plug in. Now this is where it gets a little funky. So I want you guys to try this for about 30 seconds before I give you anything. But we're going to plug in a -1 up there. Give that a shot. See what you get. I'll tell you should have a rational number as your answer.
Did you say something about not needing that?
About what?
Don't die.
Oh, no, you don't put that down. You don't need that.
Say,
It won't do you any good. Like a calculator will make things more complicated right now. It will not do you any good. Anybody confident with they know what to tell me to do? Greg? What are you thinking, man?
6 times 5.
So you, with the fan back there, you gotta speak up, dude.
6 times 5, 6 negative second.
So first, I just evaluate my exponents, combining them.
And then you put 1 over 6 times 5 to the second.
Ooh, really close. You're right with the 1 over part because the negative power tells me to flip it to the bottom. But is there a negative power on the 6? This is 6 to the first, 5 times -2. So Leon, what did you have, dude?
Like in the fraction form? Okay, so I had 6 times 1/25.
Wait, what?
So what we really, if I show all the work, it's 6 times 1 over 5 squared, which then becomes 6 times 1 over 25, which eventually, Leon,
Is just 0.24.
well, okay,
6
or 6/25. And then we could work it from there, but we can leave it as 6/25. 6 is not being affected by the negative power. Only 5 is. 6 still has a positive power. Does this make sense now? That was the mistake I was kind of anticipating. So be careful with what power actually applies to what number. Try the quotient. It's not as tough. It's a little bit more straightforward. Again, no calculators needed. Quotient of f divided by g of x. The reason that we say it, f divided by g of x, is before we ever evaluate anything involving the input, we do what has been told to us in the function name. So we do the f divided by g before we ever plug in an x. When I look at this, can I really do anything with that quotient? No, because the 4x gets divided by the 2x and the -7. The 3 is getting divided, like everything's working with like and non-like terms. There's no easy way, like there's no simplification that can be done. So since there's no simplification to be done, I'm done evaluating my function until I plug something in. So now I can say f divided by g of 12. If you don't have that yet, give it a shot. And Mackenzie? What is it? Yeah, you get 51 over 17, which simplifies out to 3. So if we were evaluating two actual situations there, since this is a quotient, what's that tell me about f compared to g at an input value of 12? Let's say my input value was months or something like that. If my input was months, what's this really telling me since I did the quotient? The amount we get from the f function divided by the amount we get from the g function just came out to be 3. Nobody has a conjecture for what this is telling me. When I do a division and it comes out to be 3, what is that telling me? If I take your height, compare it to somebody else's height, but through division and get an answer of 3, Ben?
Like just 3f for every g.
Or we could say f is
3 times g.
f is 3 times g. So after, if our input was months, we could say after 12 months, function f is 3 times that of function g. Now it would be interesting to evaluate what about in 6 months, or what about when my input's 4, or what about when my input's 2? How do the functions compare then? But that's why we're looking at comparing functions, is to be able to say, how do these relate to each other? And then if I input one value in, how can I see that relationship immediately? Try your got it there. What's a little bit tricky here? Maybe not. Maybe you don't think it's a little bit tricky, but what do we have to remember? What's really important, Straller? Yeah. So there's that we get 32x squared. Jacob?
You have to distribute before accidentally.
Yeah, this is really distributing because it's the entire function f times the function g. So if g was a binomial, we'd have to do FOIL then. But since it's not, we're just distributing. But this comes out to be 60x. So then when I plug in -5, this is all good though. Go ahead and evaluate that. I'm going to try to reorient again. My board is having a Monday.
What?
My board is having a Monday.
I heard Monday.
Hey gentlemen, do you have an answer for me yet? So this really distributed, then for all of the bonus points, 32 times 25, 800. So we get 800 minus 300. Our final answer here, 500.
I did it a lot easier.
How's that?
I just did. I distributed the -5 before. So I got -40 plus 15, and then times -20. So -25 times -20.
Okay. Questions?
Is his way valid?
It won't always hold up. So when we start composing functions where one's inside of the other or vice versa, then it falls apart.
Okay.
So for like temporarily, sure, but be careful for when it will fall apart. So, real life applications. Of course, what we always like to get to for that, ever popular, when will we use this question? So Park A, has a study going of the population in X amount of years. Obviously, when X is 0, that's the start of my study. So we want to predict the sum, the total between both parks of the deer population 4 years from now. So I plug in part A's function, I plug in part B's function, and it will make my life easier if I compose, or if I join them together first, if I do the sum first, then evaluate. Yes, for now, I could evaluate, then add them together, but it's easier to put them together first. Looking for like terms here, I've got constant, variable term, an exponential term, and then another constant. So I see I have two constants that I combine. I'm going to move my exponential term up to the front of my expression. Then I'm going to do my variable term. Then I'm going to do my constant term. So obviously I combined my 200 and my 40. Then when we plug in 4, and I jumped the steps, that's why we really only need to write one thing right there. When I plug in 4, I'm going to take that function that I just wrote and just replace every x with a 4. This, when I evaluate that little exponential group in the parentheses here, I guess I'll group that, I get 122. I get 100 out of that, and I get 240 out of there. And when I combine it all together, I see my total population is anticipated to be 462 if it keeps the same model. Obviously, if they introduced any other variables, like allowing extra hunters or protecting the area, because it told me it was deer population. Models like this is how they determine the amount of tags that people can get and the amount of tags that are available statewide. So they look at models to predict how many deer are there going to be and how many deer should we let people hunt. So based off these models, if the math was done incorrectly, we could wipe out our deer population accidentally and totally mess up the state for a long time. Yeah, or we could accidentally not hunt enough deer. The population could get out of control, and that's when people start hitting deers with their cars and everything else because there's nowhere for them to go.
That's when it goes back down.
Huh? Yeah, until we do something to make it go back down. I'm still like back where I grew up in Coshocton. There's a lot of like car deer crashes.
Wait, you grew up in Coshocton?
Yeah. Yes, it's a good town.
So are you saying I should go hunting in Coshocton?
You should. If you want to go out there, I can get you on my in-laws' property. I got 40 acres. So try this last got it. We want to see the difference in these populations. Always difference problems are slightly harder. I'm going to scoot it over so I can see the rest of my functions. Just because subtraction takes some paying attention that addition doesn't. Because sometimes you have to borrow in subtraction. So it's just inherently, it's a little bit more difficult. Do I care whether I do C minus D or D minus C? Yeah, it's going to change what my answer says. So it's either going to say C has more than D or D has more than C. Or if I get a negative answer, it will tell me the inverse of what I really thought. So if I look at these two functions, which do I think is going to have more? Let's just try to predict. Which do I think, if I plugged in a 6, would have more? C? So I agree, we have an exponential happening, but then we also take away 120 times that, but we can assume it's C. So to find the difference, let's do C minus D of X. So to do that, make sure you group 950 times 1.29 to the X minus 120x minus the entire d function, 500x minus 600. Distribute out that negative. Now I actually have plus 600 because that negative distributed. I can combine my variable terms. Are you wondering about this?
No.
Okay.
Can we just add the 600 to the 950?
No. Because that 950 is attached with the exponential. Remember, all exponentials, even if they don't show it, are in the a times b to the x form. Where a is your growth factor, b is your initial. Yeah. Because it was minus a negative. In the function, it was a minus 600. And since I took that away, we had to distribute the negative.
Okay.
Yep. So then plug in and evaluate for 6 years. So C minus D at 6 years. Now we can use a calculator.
No, we don't need it.
You can try to not use it. Might be a little difficult.
Oh my god.
Yeah, it might be a little bit.
So I always advise do your 1.29 to the 6th power, then multiply by the 950. So this comes out to be 43,077 point, we'll round up to 9, but we're going to need a whole amount eventually. 620 times 6, 3,720. So now I can combine all these values. Let's just round that up to 4,378.
Okay.
And we get approximately 1,258. My label there, we were modeling sparrows. And what's that really telling me?
There's more that many sparrows. Or in city C.
Yeah, so what that says is they weren't talking about parks, yeah, they were talking about cities. City C has 1,258 sparrows more than city D. So they'll use data and information like this.
Yeah, more sparrows.
Imagine if this had to do with bees.
Oh my.
Why would we care in a situation like this where it had to do with bees? I don't really care about sparrows too much,
Oh, I know.
but we care a lot about bees. Yeah? Steph? What? Okay, so what about it? What if I knew one city was going to have a lot more bees than the other city?
More beekeepers.
Okay, more beekeepers, but what does that really mean? Jacob?
These are really important.
Okay, what about the pollination? Why would I care where has more bees?
Oh, so
Say it louder.
You get better plants.
You'll get better plants, right? Your crops will do better, your flowers will do better. Everything that grows essentially would do better. So if you were looking at where should I put my farm or where should I grow a certain item, and you knew that this city was going to have, 1,300 more bees or bee colonies, That's really important. Yeah. They take relative populations. They'll do like how many bees are in a hive and how many hives are sustained here. So a lot of times they smoke them, which when they smoke bees, they like get all like disoriented and kind of like goofy. I know, but it's sort of like when they like give you like a gentle anesthesia like Novocaine or those things that are just like, oh, the world's all a great place. And then they can count them that way. They can pull out the hive and then the bees stay there instead of flying away. So then they'll count how many bees are in this hive. And, like they literally count bees. Yeah.